Alright, welcome back APSET. We are going to continue on with a couple examples. Example 18, we're going to draw out what the experiment would look like. Okay. So this is progress of a type of cancer differs in women and men. A clinical experiment wants to compare 3 therapies for this type of cancer. Outline a block design for this problem. Okay, so there's a couple key things that we read in how to set up this experiment correctly. We're going to be doing a block design. It tells us that, just straightforward. It doesn't always say that, but we know we're going to be doing a block design. And what we want to notice, in case it doesn't say carry out a block design, is the first sentence where it says progress of a type of cancer differs in men and women. And so that, in and of itself, is a huge indicator that gender is going to be a factor in this study. And so we need to account for that in our experiment by separating them, because somehow the qualities are going to be different. Okay. So this problem is kind of a little bit simplified in that we don't know how many men, how many women, how many subjects we have altogether. So normally you want to include that in your experiment, but we don't have that information. So we're just going to take our subjects and we are going to split them up, men versus women. Okay. So do we need to put those little R's right on the arrows, like right here? Is it appropriate to randomly assign that? What do we think? No, it is not appropriate to put a randomization right there, because are we randomly assigning people to be men? No. We know that factor about them. So in a block design, your first step is to separate them based on some characteristic that you already know about them. So the only thing that we really know in this problem is their gender. So they're separated based on gender, and that is not random. That we know about the people. Okay. So within the group of men, we'll start with, it says they want to compare 3 different therapies for this type of cancer. So the men are going to be split up into one of 3 treatment groups. So we can put it as group 1, and I'm just going to write treatment 1. We don't know what they are. We didn't specifically say what they are. So group 2 would be treatment 2. And group 3 would just be treatment 3. Now for this step, we need to label this. This is going to be random. You need to randomly assign them into different groups. Okay, and we have a couple different ways that we can do randomization. You can, stick all their names in a hat, and, the first however many people need to go in group 1, you pull out, 10 people's names and they go to group 1, pull out another 10 people's names and they go to group 2. The last part, the last 10 names, just go to group 3. You can number them in order, use the calculator to randomly select, the first 10 people go to treatment 1, the next 10 people go to treatment 2, etc., until everyone's been put in groups. And so there's different ways you can do that. And a lot of times on the AP exam, the emphasis is on describe your randomization. So describe a method of how you would randomize, or describe the random process in your experiment. So that is something that you need to be able to explain. So that divides up all the men. What we're also going to do is do the same thing for the women. So group 1 will also have, for women, we'll have treatment 1. We'll have group 2 for the women, treatment 2, and group 3, treatment 3. Okay, and so for the women, again, we're randomly assigning them to one of these 3 groups. Same thing. Same process, put all their names in a hat. The first 10 you pull out, go to treatment 1. The next 10 go to treatment 2. The remaining 10 go to treatment 3, something like that. And then you want to look at what are we going to be comparing. And again, this is kind of a simplified example where we don't know exactly what they're comparing. So I'm just going to say compare survival rates, I guess. I mean, they could be comparing all sorts of different things, like certain blood cell counts, or something that's more specific to the treatment of cancer. I don't exactly know what they're comparing, So overall, we're just hoping that it's increasing their ability to beat cancer. So that's what I'm going to write. Okay, so compare survival rates is what we're going to be comparing. All right, that takes us on to the next example. All right, example 19. A farmer wants to analyze the best way to grow soybeans. The soil type and fertility of farmland differ by location. The farmer has 12 fields, 6 north of the road and 6 south of the road. Because of this, a test of the effect of tillage type, 2 types, and pesticide application, 3 application schedules on soybean yields is done. Okay, so something that you do want to note is the soil type differs by location. So again, we're going to have to account for that, just like in the last example where gender was going to be a factor, here location is going to be a factor. So if location is a factor, we want to separate them by the different locations, okay? And then what we want to look at then is making sure that all of our treatments go into both situations, so that we end up testing the different treatments in both places. So it's not that if we end up with some, treatment that the soybeans grew a great deal, we need to know that it wasn't just because it was south of the road. We need to also have tested that north of the road to make sure it's not just the factor of location that's affecting things. Okay, so I kind of spelled that out. What should this experiment be blocked on? And it's on location, so of the fields. And specifically, we're talking about north of the road and south of the road. What are the factors? That's the same thing as like, what are the 2 variables? Well, there's 2. What are the 2 variables that we're going to be looking into the effects of? And the 2 things that we're looking into are tillage type and the other thing is pesticide application. All right, what are the levels? So when you break down those 2 variables, the factors, what type of levels are we going to talk about? And then in here, we don't specifically know the different types. It's not spelled out for us. So the tillage, though, they tell us that there's going to be 2 types, and the pesticide, there's going to be 3 types. So what I can write is the tillage type. I'm just going to do like level 1 and level 2, L1 and L2. Not like the list in the calculator. You could have put T1 and T2, doesn't matter. And then the pesticide application. They told us that there's going to be 3 different types of pesticides. So I'll just label them pesticide 1, pesticide 2, and pesticide 3. So then how many treatments are there all together? Basically, you multiply these 2. It'd be like a 2 by 3 table, so there's going to be 6 treatments. Okay, so let's go ahead and just label those over on the side just so we see that there are 6 treatments. So I'll just label them like T1. So treatment 1, we could have the tillage type 1 with pesticide 1. Treatment 2, we could have tillage type 1 with pesticide 2. Level 1 with pesticide 3. And then we're going to do the same thing for level 2 of the tillage. So we can have pesticide 1, pesticide 2, and treatment 6. Tillage type 2 and pesticide 3. So those are our 6 different treatments. Okay. We want to outline a block design. Okay, so block design, you separate it again based on some characteristic that you know. So this part is not random. So we're going to take our 12 plots. road's a factor, so we're going to separate them north of the road. And we have 6 plots here. And we're also going to do south of the road. And here there are 6 plots. And so we have 6 treatment groups. There's 6 plots both north and south of the road. So of the 6 plots in the north, we are randomly going to pick like the first one to go to a treatment. Okay, randomly assign one of those to treatment 1. So I'm going to put the R for random. Randomly assign them to treatment 2. And I'm just going to do ... here. And randomly assign to treatment 6. And so here we're just having one plot for each of these, so that all 6 plots are assigned to a different treatment. Okay. We're going to do the same thing for south of the road. We're going to randomly assign one of the plots to treatment 1. Randomly assign it to treatment 2. All the way down to treatment 6. So that all 6 plots are randomly assigned to one of the 6 different treatment groups. And then what we want to compare after we do all these different types is compare the soybean growth of soybeans. To see if one of the treatments significantly improves the growth of the soybeans. Okay, so we blocked it based on a characteristic that we know. Over here, north of the road, south of the road. Again, we didn't randomly decide that those are known characteristics because the location is being a factor. And then within there, we had 6 plots, so we're randomly going to assign them to one of the 6 treatments. Do the same thing for south of the road. And then we want to be able to compare the growth of soybeans to see which treatments helped grow soybeans.